Okay, for this is example number 2. We want to make sure that we can sketch some of the reciprocal functions. So we're going to take a look at 3 examples of sketching the reciprocal functions. Let's take a look at A first. So we want to sketch 2 full periods, and in that we want to include the amplitude, we want to include the period, we want to include any type of vertical asymptotes that it has as well. So anytime we're sketching either cosecant or secant, the first thing that we want to do is we want to sketch their reciprocals, and cosecant goes hand in hand with sine. So what I'm going to do is I'm going to use the graph of y is equal to 5 sine of x minus pi over 4 to help me figure out what the graph of y is equal to 5 cosecant of x minus pi over 4 looks like. So we're going to start here, and we're going to use that information to end us up over here. So let's take a look at some information that can help us graph this function. So remember, when we're sketching sine starts at 0 and ends in 2 pi. We do have a phase shift, so we're going to set each argument equal to the endpoints. So we have x minus pi over 4 is equal to 0, and x minus pi over 4 is equal to 2 pi. That means instead of starting at 0 and ending at 2 pi, now we're going to start at pi over 4, and we're going to end at 2 pi plus pi over 4. So we have x is equal to 2 pi plus pi over 4. Which is the same thing as saying 2 plus a quarter is 2 1/4, 2 1/4 pi, which is the same thing as saying 9 pi over 4. 4 times 2 is 8, plus 1 is 9 pi over 4. So normally, again, we start at 0 and we end at 2 pi. This time we have a phase shift of pi over 4 units to the right. So now we're going to start at pi over 4 and end at 9 pi over 4. In regards to amplitude, we have an amplitude of 5. Okay, so let's start sketching this information that we know. All right, oops, you know what? I do not want to use this color, sorry. Let's use black, and let me just sketch something here. I can do it like this, that's absolutely fine. All right, so let's start here at pi over 4. We're ending at 9 pi over 4, and what we need to do is we need to figure out what those critical values are, and I asked for 2 periods of the function, so actually we're going to extend this. Okay, so we're starting at pi over 4, and we have 9 pi over 4, so our period is still 2 pi. And remember, in order for us to find what these critical values are, you take the period and divide it by 4 and then continuously add it. So 2 pi divided by 4 is equal to pi over 2, or 1/2. So we're going to continuously add pi over 2. And again, 1, 2, 3, because we asked for 2 periods of the function, we're going to do that all the way down the number line over there. So pi over 4 plus pi over 2 is the same thing as saying pi over 4 plus pi over 2 is the same thing as saying 3 pi over 4. So this is at 3 pi over 4. Plus pi over 2. That is the same thing as saying 5 pi over 4. We continue, this is going to be 7 pi over 4. So I hope you can see there's like a little bit of a pattern here where we're just adding 2 pi to the numerators, and the denominators are going to stay the same. Let's continue with that trend. 9 pi plus 2 pi is 11 pi over 4. 11 pi over 4 plus 2 pi is 13 pi over 4. 15 pi over 4, and then we end up with 17 pi over 4. All right, now we also know that we have an amplitude of 5, so we're going back and forth between 5 and negative 5. Okay, let's see what other information we can garner from this. So, okay, we're graphing sine. Remember, sine starts at 0, so instead of starting here at 0, now we're going to shift that over to pi over 4. So we're going to start here, go up, come back down, go down, come back up, and this is 1 complete period, and then we can do it again. Up, down, down, back up again, and this is 2 complete periods. Okay, so this is what our function looks like. So we just sketched this function. We just sketched y is equal to 5 sine of x minus pi over 4. Now what we're going to do is we're going to use the fact that we're not dealing with sine, but we're dealing with cosecant, which is its reciprocal. So here are the following rules. Anytime we see a 0, that's going to turn into a vertical asymptote. So we're going to have a vertical asymptote here at pi over 4. We're going to vertical asymptote here at 5 pi over 4. We're going to have a vertical asymptote here at 9 pi over 4. We're going to have a vertical asymptote here at 13 pi over 4. And we're going to have a vertical asymptote over here at 17 pi over 4. Now, another cute thing to remember is when you're graphing these functions, all of the zeros become vertical asymptotes, and all of the peaks, see we have a peak up here, now become valleys. All right, so that's what that piece of the function looks like. Let's see if we can just, oh, there we go. This used to be, I don't remember, it used to look like this. That was a valley. It's now going to become a peak. This right here is a peak. It's now going to become a valley. This is a valley, and it's now going to become a peak. So this is a graph of two periods of the function y is equal to 5 cosecant of x minus pi over 4. Pretty neat, huh? Let's try the next example. So let's go to this one. Y is equal to negative 1/2 secant x over 4. Y is equal to, oops, sorry about that. I want that to be positive 1/2. Y is equal to positive 1/2 secant of x over 4. Okay, now when we're graphing, again, just like we did before, when we're graphing secant, we're going to start off and we're going to graph the reciprocal function first, which is y is equal to 1/2 cosine of x over 4. So let's start off by graphing y equals 1/2 cosine x over 4. Once we get that graph, then we're going to use the zeros become vertical asymptotes, peaks becomes valleys, and valleys become peaks part. All right, so 1/2 cosine x over 4. Again, the first thing we're going to do here is we're going to figure out what our period looks like. I don't have any type of phase shift in here, but I do have an issue with my period because we are multiplying our function by 1/4. We're multiplying our argument by 1/4. So remember, the period is going to be 2 pi divided by whatever number stuck to our variable. So it's 2 pi divided by 1/4. Which is the same thing as saying 2 pi divided by 1/4. That's the same thing as saying 2 pi times 4 over 1. And that's the same thing as saying 8 pi. Okay, so we don't have any type of movement left to right, any type of horizontal movement. What we do have is we have a horizontal... Let me review what I just said. We don't have any type of... we don't have any type of horizontal shifting. We do have a horizontal stretch, and we have a horizontal stretch by a factor of 4. Normally, our one complete period starts at 0 and ends at 2 pi. Now, one complete period is going to start at 0 and end at 8 pi. So this is one period. Okay, and remember, again, in order for us to figure out what our critical points are going to be, we're going to take our period, we're going to divide it by 2, so 8 pi divided by 2 is 2 pi, we're going to constantly add it to the next endpoint, so 0 plus 2 pi is 2 pi, 2 pi plus 2 pi is 4 pi, 4 pi plus 2 pi is 6 pi, 6 pi plus 2 pi is 8 pi, and again, because we're doing two periods, let's go to the left this time. It doesn't matter, you can go to the right or the left. Now we're going to subtract 2 pi, so 0 minus 2 pi is negative 2 pi, negative 4 pi, negative 6 pi, and negative 8 pi. Okay, so we have two full periods of cosine right now in terms of their critical values. And if you take a look over here, we have an amplitude at 1/2, so that means we're going to go from positive 1/2 to negative 1/2. All right, now cosine, remember cosine normally starts at 1. Now, because we have an amplitude of 1/2, we're going to shrink it by a factor of 1/2. So let's draw one complete period of cosine on this side. Let's draw one complete period of cosine on this side. And we get a function that looks like this. Okay, so here's our cosine. Now we're not graphing cosine, we're graphing secant. So we're going to use the rule in secant. Anytime we see a 0, that's going to become a vertical asymptote. Vertical asymptote, vertical asymptote, vertical asymptote. So we have vertical asymptotes at negative 6 pi, negative 2 pi, 2 pi, 6 pi. And again, we could have continued to the right or continued to the left. And now our peaks become valleys and valleys become peaks. Okay, so this is a peak. It's now going to become a valley. This is a valley. It's now going to become a peak. This is half a peak. It's now going to become half a valley. This is a valley. It's now going to become a peak. This is half a peak. It's now going to become half a valley. And this is what 2 complete periods of this function looks like. Y is equal to 1/2 secant x over 4. Let's try one more example. The last example, let's take a look at y is equal to -3 cosecant of 4x. Let's see, y equals -3 cosecant of 4x. Ooh, sorry about that. I can't write right now. I hurt my finger. Okay, first things first. Let's first figure out what our new period is. Notice that we have a number attached to our argument. So, oh, you know what? Even before we do that, let's rewrite this as its reciprocal, which is y is equal to -3 sine of 4x. So we're going to sketch that first and then use the sketch of that to help us figure out what -3 cosecant of 4x is going to look like. Okay, so normally we have a period of 2 pi. Now our new period becomes 2 pi divided by the number stuck to our x value, which is 2 pi over 4, which is pi over 2. Okay, so we have a horizontal shrink. We also have an amplitude of 3. Notice that it's negative, so we're going to reflect. Okay, so we're going to start here at 0. We're going to end here at pi over 2. And when we take our pi over 2 and divide it by 4, that's going to give us pi over 2 divided by 4. Is the same thing as saying pi over 2 times 1/4. That's going to give us pi over 8. So in order for us to figure out what our critical values are, we're going to add pi over 8. So 0 plus pi over 8 is pi over 8. Pi over 8 plus pi over 8 is 2 pi over 8, which reduces to pi over 4. Again, it's also 2 pi over 8. 2 pi over 8 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 is 4 pi over 8, which reduces down to pi over 2. Again, because we want to do 2 complete periods, I'm just going to continue to extend this out to the right. 4 pi over 8 plus pi over 8 is 5 pi over 8. 5 pi over 8 plus pi over 8 is 6 pi over 8. That just reduces to 3 pi over 4. 6 pi over 8 plus pi over 8 is 7 pi over 8. And 7 pi over 8 plus pi over 8 is 8 pi over 8, which reduces down to just pi. Okay, and now we have our amplitude at 3 and -3. And because we're dealing with a negative, that means it's a sine. Sine normally starts at 0 and goes up to 1. Now it's going to start at 0, go down to pi over 8. Come up to pi over 4, go to 3, end at pi over 2, so it's 1 complete period. Let's continue with this trend. Go down, up, up, down, and this is what 2 complete periods of -3 sine 4x looks like. Now let's use the fact that it's a reciprocal. Remember that zeros become asymptotes. Zeros, you guys are all going to become asymptotes. Peaks becomes valleys, and valleys become peaks. So this is a valley. It's now going to become a peak. This is a peak. It's now going to become a valley. This is a valley. It's now going to become a peak. And this is a peak. It's now going to become a valley. Let's just erase this old guy here. And this is what 1 complete period of this function looks like. So we have, this is also a vertical asymptote, so there's another 0. We have vertical asymptotes at 0, pi over 4, pi over 2, 3 pi over 4, and pi. Zeros all become vertical asymptotes, peaks become valleys, and valleys become peaks.